Jim Hansen, the great
Yes.
former director of NASA, says, you know, we're at 1.5, and I think we are. And if you've got a sequence of numbers that is rising, an average of 20 years is going to tell you what the situation was 10 years ago. Global greenhouse emissions from human cause are still going up each year. Total emissions in 2050 will be likely only 5% lower than now. A lot of the warming in the next 5 years is not just caused by the emissions in those 5 years, but the emissions in the past 20
Right.
years. The IPCC, in their 2018 special report on 1.5, had a range of when we'd get to 1.5, but the midpoint was 2040. The elite don't want to get the problem. The politicians in Canberra internationally, they go to conferences and people talk about keeping 1.5 alive and we will honour the Paris Agreement and, we've got net zero and we've got all these possibilities and they believe it because that's what they hear all the time.
True.
Central Asia, I mean, Kazakhstan, Uzbekistan are completely dependent on meltwater because it doesn't rain there.
Hello, everyone. Welcome to another episode of Science Talk. I'm your host, Dr. Mohammed Itafaq. In today's episode, we are talking about the world which is warming at maybe 3 degrees Celsius, or we are accelerating it with a rapid pace right now, and we already reached 1.5 degree, or maybe we haven't reached 1.5 degree. Who knows? But I'm joined by David Spratt. He's an Australian climate policy analyst and research director at Breakthrough National Center for Climate Restoration. Uh, David, thank you so much for your time and welcome to Science Talk.
My pleasure.
So let's start. I always like kind of struggle with how to start with a guest, but I'm gonna start with a question. Where we are in terms of climate change. We can start the conversation from there.
Well, I mean, this is a very interesting and a vexed question because in climate and even in climate science, things are not always obvious.
Hmm.
So, I mean, practically speaking, in 2023, we had 1.5 degrees.
Hmm.
Last year in 2024, we had 1.6 degrees.
Hmm.
This year we'll have somewhere between 1.45 and 1.5. So it's clear that the average of these 3 years will be 1.5.
Hmm.
And I mean, some of the world's leading scientists, my personal hero, Jim Hansen, the great
Yes.
former director of NASA, says, you know, we're at 1.5, and I think we are. And yet we have scientists saying, oh, no, the average is only 1.2. And here's the problem, and it's a problem of science communication.
Yes.
That scientists have this definition that the current warming is the average of the last 20 years. And if you've got a sequence of numbers that is rising, an average of 20 years is going to tell you what the situation was 10 years ago. I mean, I think it's like, when you're a child and you each year you mark your height on the wall with a pencil. So you've got all the marks, and when you get to an adult, you get all those marks over 20 years, and you add them up and you take the average and you say, oh, that's a person's height. But it's not.
Yeah.
The average is their height 10 years ago. So, I mean, I think for all practical purposes, we're at 1.5 and the rate of warming clearly has accelerated from about zero point 0.2 to about zero point 0.3 degrees. So that's, I think, physically where we are.
So that's where we are, and that is how do we know that we are here because of the satellite data,
Yeah.
right? We are collecting the data every day, every month, every year, and then at the end we kind of try to calculate to see the pattern because it says it's not a linear, right? It kind of
Mm.
sometimes it's higher, sometimes it's lower, but we take the average, right?
Yeah, and so yes, there's natural variation. There are years that are hotter and cooler. I mean, the most interesting is the fact that when we have El Nino years, which
Hmm.
in Australia means hotter temperatures and drought and more fires, in El Nino years they tend to be a bit hotter
Hmm.
because of the change in the Pacific circulation, and a bit of heat basically comes from the ocean into the atmosphere. And in La Nina years, which we have now, they're a bit cooler. So it's interesting that 2 of these 3 years where we've had 1.5 have been La Nina years, cooler years.
So, so once we stay in that range, it means that it's not possible that we're gonna go back to 1 degree or below 1 degree in next 5 years or something. It's until or unless we do
Mm.
drastic changes, it's gonna keep rising, right?
Well, there's never 100% in science or in the world, but I mean,
Yes.
it is so unlikely. It's 99.99%. I mean, I think we have to understand is that what's driving this warming, what's driving this accelerated warming, because that will
Yes.
apply for the next period as well.
Mhm.
So, uh, global greenhouse emissions from human cause are still going up each year. We haven't reached peak emissions yet. Um, if you have a look at the recent production gap report done by the UN and a whole lot of science institutions, um, they're basically saying that total emissions in 2050 will be likely only 5% lower than now from
Mhm.
coal, oil, and gas. And in fact, they show that for both oil and gas, the fossil fuel industry, petrostates are all planning to increase production. That's the bitter truth. So we're going to continue with high emissions, which is, I mean, in Australia's a petrostate in the sense that we're together the third largest exporter of coal and gas in the world, and
Oh, wow.
our our government keeps on licensing new gas projects, and each new license is another suicide note for part of humanity. I mean, that's what it is. So emissions are going to continue to be high. We've also have to understand that a lot of the warming in the next 5 years is not just caused by the emissions in those 5 years, but the emissions in the past 20
Right.
years.
Yeah.
So we've got that whole backlog, what's called thermal inertia, to come
Yeah.
through. We've also had a process which has led to the increase in the rate of warming around sulfate aerosols. So sulfate aerosols are a product of largely of burning fossil fuels. I mean, we know of what's called dirty coal or dirty
Yeah.
oil, which has a high sulfur content. And when you burn that, it produces sulfate aerosols, which have a very strong but short-lived cooling impact. They only last a week in the atmosphere and they get rained out, but we keep on putting them out there. I mean, they're the product of, they're what have caused acid rain. So there are policies around the world to reduce sulfates for
Mhm.
health reasons, particularly in China and particularly with maritime shipping emissions, because bunker fuel has been very sulfate heavy. And that reduction in sulfates has drawn away, removed some of that temporary cooling and produced that increase in warming, and that will continue. I think the other things that will have an impact on the future warming is the fact that some of what some of the Earth systems which draw down carbon are becoming less efficient. I
Mm.
mean, we've seen this, for example, in the huge forest fires. I mean, whether it's in Canada or the United States or here, the land sink, the capacity of the land system to draw down carbon is reducing. I mean, there are parts of the Amazon rainforest which have now become net emitters. There are
Mm.
bits of permafrost that become net emitters. It's also probably true that the capacity of the ocean, which draws down a lot of the CO2, is becoming slightly less efficient. So altogether, we can see a lot more emissions in the
Yeah.
atmosphere in the next 20, 30 years, given the incapacity of the world to reduce coal, oil, and gas use, and that will drive warming, I think, at this increasing rate. What Jim Hansen says, about zero point 0.3 degrees a decade, which means we'll be at 2 degrees around 2040 or so.
2040, yeah.
Yeah,
So this 1.5 degrees Celsius arrived earlier than IPCC
yeah,
projections, right?
yeah.
How did they get it? Did they get it wrong, or this is how it works? Like, this is how the climate science work. Explain that. Like, what did they get wrong? Or is it really impossible to predict over 95% confidence interval, whatever?
Well, yes. I mean, climate science is evolving all the time. I
Mhm.
mean, for example, we know that global warming has destabilized the Arctic climate system, and so the jet stream, the circulation that runs around the Arctic, has become destabilized and doing big S bends, and that's bringing incredible cold into North America and incredible heat into the Arctic. I mean, that wasn't known 20 years ago. So, of course, we learn more. The IPCC in their 2018 special report on 1.5 had a range of when we get to 1.5, but the midpoint was 2040.
Yeah.
And we've got there
That
in
that's a
25. We've got there.
major that's a huge
That's a
miscalculation.
stuff
Like,
up.
Like
That's
2050,
a stuff.
that's 15 years earlier. Yeah.
Yeah, that's a stuff up. And I mean, some people, I mean, Jim Hansen for years, I mean, I was looking back some old blogs of mine 5, 10 years ago, was saying because the aerosol production will reduce, we're going to get accelerated warming. But it wasn't listened to because, I mean, one of the problems is that, all these projections of future warming and impacts are based on models,
Bit different
which
model.
is
Yeah.
mathematics and equations.
Yes.
And if you can't put a number on something, if you can't put a time on it, if you can't quantify it, then it's not in the model. And this is one of the problems that a lot of the big system tipping points, I mean, Arctic ice sheets, the Amazon is very difficult to model. And if you can't model, it's simply excluded. And in
Yeah.
that
It's not
exclude, in that,
accounted for. Yeah.
yeah, and in that exclusion, you miss things that are important.
That's interesting. So like IPCC has their own modeling. That's how they collect the data. They don't rely on
No,
other third parties
no,
to model.
they rely on, I mean, a group of models which are put together and updated. It's called CMIP. I think we're up to six community model uh, project.
Mhm.
So they use standard models which are shared around the world. So I think that's okay, but those models don't account for anything. I mean, many parts of the climate system are what people call non-linear. So there's things in the climate system that we know very well. You put more CO2, carbon dioxide in the atmosphere, it will get warmer. Every 1 degree of warming adds, that means the atmosphere can hold 7% more water vapor. So you get heavier rainfall. I mean, these are linear processes, but many of the processes are not linear. I
Hmm.
mean, an ice sheet um, tends to collapse in a non-linear way, according from the paleoclimate data. It's very hard to model the Amazon. We've had the question of the Atlantic circulation, AMOC,
Mhm.
which
Yeah.
carries all that heat from the Caribbean up to North America. And now there's work that's just been done by incorporating it into models in a way which wasn't possible before, saying we're at the point of collapse there. So it's this non-linearity, this problem of quantification that means that models should not be the only source of information. And this is people that Jim Hansen and many others have said, as well as models, we need to look at climate history. I mean, climate
There are
history,
too many data points. There are too many
yeah,
data
yeah.
points. Yeah.
And climate history is important, and so is what they call semi-empirical models. I mean, for example, um, uh, in the last ice age, it was about 5 degrees cooler,
Mhm.
and the sea levels were 100 meters higher, 100 meters lower,
So,
sorry. So you can work out from that, and you can go back through the paleoclimate thing, and it will tell you that in the long run, every 1 degree will produce 10 to 20 meters of sea level rise. I mean, you can draw a line through history and show that. And yet we have the IPCC saying, oh, look, we could have 3 degrees of warming by 2100, but the sea level rise will only be 1 meter. Now,
mm,
it takes time, but
yeah.
that's an underestimation that
Mm.
I think produces a false sense of security.
So the conservative estimates are not helpful, because then we're not going to act, right? We just like we still have time. We can buy some
Mm.
time. We don't have to act because it's only 1.5 by
Yeah,
2040, meaning we still have 15 years. But if we have overestimated or accurately estimated, that
mm.
could have been accelerated the actions that
Yeah,
different
yeah,
governments would take.
yeah. Well, I mean, for example, I mean, at Paris and international policy making fora, they keep on
Mhm.
saying net zero by 2050. And that was based on the models which said we'd have 1.5 by 2040.
40. Hmm.
Now we've got 1.5 by 2025, 15 years early. So
Yeah.
if they were saying net zero 2050, logically today they should be saying net zero 2035 because we've lost 15 years out of the system, but they
Yeah.
don't. So
Yeah.
this is the disconnection between science and politics. I mean, I guess the other thing is about risk. For example, I mean, it's really clear, and some of the world's leading scientists say we are heading, if we get to 3 degrees, we're heading towards civilizational collapse.
Yeah.
I mean, this is not rocket science. And that means it's what we many years ago called an existential risk. That is a risk that it won't end humanity, but it will destroy the global and national and regional social and economic systems and systems of cooperation that make the world possible as it is today. And in any risk management system, uh, if the risks are existential, you must look at the plausible worst case scenario and
Yes.
stop it.
Yeah,
I mean,
true,
that's what we did.
true.
That's what we did with nuclear weapons. I mean, in
Yeah.
a way, that's what we did with COVID.
That's
If
what insurance companies do, right?
it's what it's what insurance companies do. I mean, if we were to walk in onto an aeroplane or into a lift or
Yeah.
over a bridge, and they said, "Oh, there's a 10 or 20 or 30% chance of it collapsing," you go, "No,
Yeah,
I
absolutely.
want a 0.001% chance of
Yeah.
this." And so, I mean, the IPCC report in 2018 said 1.5 could be basically between the late 2020s and 2055 or something. The midpoint's 2040. And
Hmm.
everybody said 2040. But what they should have said, the plausible worst case scenario is the late 20s, and that's what we should base it on.
Yeah,
I
exactly.
mean, people won't put their children on a swing if
Mm.
there's a 10% chance of it collapsing,
Yeah,
but
absolutely.
those same people will adopt a carbon budget, which
Yeah,
have a 50 or a 33% chance of exceeding a bad number. So this is the
absolutely.
risk management problem.
Yeah. So you mentioned net zero by 2050, the IPCC, but
Hmm.
now it should be 2035. What is net zero and how do we get it?
Oh, I wish I wish I knew. I think it's a figment of policymakers sort of conniving to appear to be doing something reasonable and just deferring. I mean, anytime you set a target, this was set in 2015. So that was set for 35 years in the future. And I mean, governments don't last normally more than 3 or 4 or 5 years, and company directors 10. So a target that far in the future is just an act of procrastination. Ah, the second problem is that it said net. And if
Mm.
you look at the 2015 Paris Agreement, in that is all this stuff about basically, and the scenarios that companies and the International Energy Agency and others have put out since then show that with net zero 2050, you don't stop using fossil fuels.
Mm.
You're still using about half as much as you are now. And then
Yeah.
you've got these wonderful offsets or drawdowns. So things like bioenergy with carbon capture and storage and so on. I mean, technologies which are not demonstrated to be viable at scale. It's a bit like the Catholic Church in the Middle Ages selling indulgences. You
Yeah.
know, you sin, you emit all this CO2, and then you go and put some money down, and you get excused for your sins and go and do it again. So I mean, that's the problem. I mean, the other problem is that if you think about it, we have got 1.5 now,
Mhm.
right now. We know that now is already dangerous. I
Yes.
remember about 10 years ago writing a
Yes.
paper saying, is climate change already dangerous? Now we can see the danger. I mean, whether it's the fires in California or the floods, and the big system things. I mean, it's now clear that the world's coral reefs are in a death spiral. We see it in Australia with the Great Barrier Reef. It is clear back in 2014, Eric Rigno said and demonstrated that West Antarctica had passed its tipping point. I think it's pretty clear that Greenland has passed its tipping point. The Amazon is right on the edge of passing its tipping point. I mean, even AMOC, the Atlantic circulation, I mean, which carries all this heat from the Caribbean up the east coast of North America and then into Western Europe. Stefan Ramsdorf, who's basically the world's leading expert on this,
Mhm.
was the author of a recent paper, and he said, and what they did was they used a whole lot of standard climate models,
Mhm.
nothing particular, and they
Yeah.
ran them out to 21 past 2100, and all 9 models showed that the AMOC would slow and collapse over 100 years. But he said, we found that the tipping point when the shutdown becomes inevitable is probably in the next 10 or 20 years. You know,
That's a
and
significant difference. Yeah.
man, I mean, and I mean, I think there's some confusion about tipping points. If you think about it, I mean, a tipping point is when you have conditions that
Mhm.
nothing more needs to be done to produce a change. I
Yes.
mean, let me
Yeah.
give you a really practical example. You've got an ice block in the fridge. You take it out of the fridge and put it on the table. As soon as it's put on the table, it's past its tipping point
Yeah, because it's gonna start
because
melting. You can't stop
it's
it.
going to start melting.
You
You don't
can't
have to,
stop it. Yeah.
you don't have to turn the heater on. You don't have to do anything. It's
No.
changed its circumstances and it will now melt of its own accord. And in that sense, I mean, it sounds like the AMOC has already reached that point. I mean, and this is, I mean, yes, it will take a long time, but its effect will be felt and build up. And if the AMOC slows, you'll have cold periods in Scandinavia of minus 40 to 50 degrees.
Mm.
I mean, research scientists say that agriculture will be non-viable in
Mm.
Ireland and the UK and northwestern Europe. And this is, you know, this is like so big it's hard to get your
Yeah,
head around.
absolutely, absolutely.
But
So,
I mean,
so that means that we are already reaching various tipping points where it
yes,
means that these things are irreversible. We cannot stop them. And this warming is already continuing because the recent report shows that 2024 was a record high coal production and use,
yeah,
right?
yeah,
And we're
yeah,
still continuing warming the planet. And it
yeah.
means that even if we stop using fossil fuel, the warming will still continue for the next few years at least, because
It
it.
will warm a bit and then it will stabilize. But I mean, the fact is that I think even if you stabilize the temperature now at 1.5 or in another 10 years at 1.8,
Mhm.
that would not stop a whole
Yeah.
lot of these systems change. I mean, if we look back at climate history, for example,
Mhm.
there's some recent work which shows that the amount of carbon dioxide now is more than any time in the last 16 million years.
Yes,
So,
yeah, I
so
saw that too. Yes.
over the last 15, 16 million years, we've never had CO2 greater than now.
Yeah.
Um, Yet there's very clear paleoclimate data that uh, around 4 million years ago, where CO2 was less than now, about
Yeah.
400 as opposed to 425. Back then, temperatures were 3 degrees warmer, sea levels were 20 to 25 meters higher.
Higher. Mhm.
There was no ice on Greenland, and beech trees were growing in Antarctica for less CO2 than now. So, I mean, the idea, I mean, coming back to net zero, the idea that we still got a carbon budget left is mad.
Yeah.
I mean, when people say to me, "Oh, how much carbon budget? When will you be at zero?" And I keep on saying, yesterday. And I'm not being silly. I mean, it's actually
Yeah.
true. I mean,
Yeah.
we should have been yesterday. So, um, I mean, we had a great Australian scientist called Will Steffen, who's no longer with us, who was the lead author of a famous 2018 paper on hothouse Earth, where he said the various sorts of feedbacks we're talking about, it gets warmer, you melt ice, sea ice, that changes the Earth's reflectivity, you get more heating, forest burn, that puts more CO2, more. I mean, these are cycles that
Yeah.
wind up on themselves. And they said you can get to a point where the Earth would continue to warm even if humans didn't put coal and gas and oil in the atmosphere, because these other systems in the carbon cycle would be so primed. And he said back then, and I'll quote, even if the Paris Accord of 1.5 to 2 degrees rise in temperature is met, we cannot exclude the risk that a cascade of feedbacks could push the Earth system irreversibly onto a hothouse Earth pathway.
Mm.
Mary said, "Oh, it couldn't really be true," but I mean, it now does appear to be true that
True.
in many ways the climate system is more sensitive to temperature change than people thought. I think that's one of the big lessons. I mean, climate models have got future warming pretty much right, but the way at which these systems, the ice sheets and the forests have reacted is beyond it. And we're now maybe on the edge of that system. So absolutely 2 degrees is no good, but 1.5 is no good either.
Yeah, it's not, but we already reached that. And now, like they were saying recently, the coral reef was the first climate tipping point. Was it really first climate tipping point, or we already have a couple of other
Uh,
tipping points?
I think Tim Lenton was being conservative. I mean, to come back to our ice block example, I mean, I think he's saying a bit, once the ice block's out of the fridge, it hasn't reached its tipping point. You've got to wait till it's half melted, and
Yeah.
then you can see that it's really melting. But I think that's wrong. I mean, clearly I worked with some coral scientists here who said because the problem with coral reefs is that when you get ocean heat waves, they bleach, they kill the organisms within them, and it takes them 10 years to recover. So if you have bleaching more rapidly than 10 years, you're just in this cycle of never being
Yeah.
able to recover. And the world's greatest expert on coral reefs said to me, if you wanted to keep the barrier reef healthy,
Hmm?
you'd want to keep warming under half a degree. And when
Not the
Eric
case.
Rigno, yeah, and when Eric Rigno produced his great paper on West Antarctica and Thwaites Glacier in particular in 2014 or 13, saying this is past its tipping point, we said to him, well, what do you think the temperature was practically when it passed this tipping point. And he said, look, around about point 0.8. Warming was about 1 degree then,
Mm.
about point 0.8. And so it's clear that there's all sorts of systems that are only stable under a degree, for coral reefs under half a degree. And
Mm.
so we do have scientists now saying, if you want to preserve the world where humans can live and they can live on river deltas and having cities by the coast, you need to have pre-industrial conditions.
Which is idea for degrowth, which is not happening either. So one of the quote I'm quoting from the report you shared with me is the 1.5 degree is dead, 2 degree is in agony, and 3 degree is looming. That's quote from
Mm.
Professor Hans, I believe. He's in Austria.
Schellenhuber.
Yeah.
Yeah.
So and that 3 degree is terrifying.
Of course, of course. I mean, John Schellenhuber is, I mean, one of the greatest thinkers on climate in the world. I mean, he was director of the Potsdam Institute for 20
Mhm.
years. He advised Angela Merkel, he advised the EU. I mean, a truly brilliant man. And he
Yeah.
tends to be very, very direct. And he's
Yes.
saying, we're past 1.5, we're going to crash through 2. And I mean, even the chair of the IPCC, Jim Skier, said, unless we do more than we are now, we'll get to 3 degrees.
Oh, wow.
We had a survey that the journal Nature did a few years ago of 200 IPCC scientists asking what they thought, we'd get to, and about 60% said 3 degrees or more. So that's what the scientific community thinks.
Yeah.
And yes, that is that is that is truly frightening because um, from any point of view, I mean, whether it be sea level rise, whether it be extreme heat, I
Yeah, or
mean,
the
for
crops
example.
production or food demand or
The
droughts
food,
and
the food
everything. Yeah.
production at 3 degrees. I mean, there's an interesting, and I mean, and you don't have to listen to climate activists to get this sort of story. I mean, in the UK, the main foreign affairs and security think tank for the British government is called Chatham House, famous
Yes.
for,
Mhm.
Ch for Chatham House rules, where you can have a conversation but you can't attribute it afterwards. And they did a climate assessment report in 2021, which I think is the most brilliant, really easy to read, beautiful piece of communication, very clear. Um, and they said, unless emissions reduce really quickly over the next 10 to 15 years, which hasn't happened and
Which
won't
has in 4 years
happen.
are already gone. They said in
Yeah,
2021.
they said between by 2040, 2050, let's say 2050, they
Yeah.
said by then we think that the world population will have grown by 50%, which is
Mhm.
reasonable. That's
Yeah.
2% a year. And that crop yields will be down 30%. And you put those two numbers together, and you end up, with something which is unbelievable.
Yeah.
I
I
mean,
mean,
sorry, no,
like, I
not
mean, like, look
population.
at like we already have a food insecurity, and just imagine if you have a 35%, reduced in crops, what the world is going to look like in terms of food
Of
security and
course,
malnutrition and all those issues.
of course, and for example, I mean, the World Bank 20 years ago did a thing on Asia, and Vietnam is the world's third largest exporter of rice,
Mm.
and the Mekong Valley is really low.
Mm.
And they said by 2050, we can see a scenario where you get a flooding event, I mean, a cyclone, onshore winds,
Yeah.
where 90% of the Mekong will be salinated in an event. And of course, once a rice paddy is salinated, you can't grow rice in it anymore. I mean, that's just one
One
example.
example. Yeah. So
Uh,
just
and
just go ahead.
yeah, and also we're going to have heat in much of Asia and other
Mhm.
places, but
Yeah.
Asia is the greatest population, particularly in South Asia.
Yes.
uh, um, uh, of heat which will be beyond the stress level of rice to germinate.
Yeah,
And so,
absolutely, absolutely. We have like already in Pakistan it goes 56 degrees Celsius sometime during
yeah,
summer, and it's unbearable
and,
during
and
those
and crops
times.
cannot survive.
No,
So, I
no,
mean,
absolutely
uh,
cannot.
change less water off the Himalayas because Pakistan in particular is really dependent on meltwater rather
Yes.
than rainwater. In India,
Mhm.
overconsumption of groundwater has meant that the water table has dropped, and there are cities where they have to tank water to. I mean, we're heading towards a water, food, heat, cyclone sea level rise crisis that in Asia and many other places means that, I mean, governments won't survive.
Yeah. And that
You,
that's my next point is that we already India, Pakistan, they're already starting to trying to have a war on the water because those rivers come from India and Kashmir region, and then when it rains a lot, they open the gates of those dams and it floods the half of the country. And how is that going to impact the countries in terms of conflicts or national security? Because your food, your agriculture, your water, everything depends on these events.
Well, I mean, this is one. Well, it was actually one of the early climate security risks identified because, I mean, all the great rivers of Asia, whether they end up in Pakistan or
Mhm.
India or Bangladesh
Yes.
or the Mekong and down Southeast Asia, and the big rivers in China, all arise in the Himalayas and the Tibetan Plateau. And
Mm.
the Chinese are damming them, and so some Chinese rivers don't make it to the sea anymore, and the contestation over water will become acute.
Yeah.
I mean, if you look at Central Asia, which people don't talk about very much, I
They
mean,
don't- Yeah,
it's
that's true.
Central Asia. I mean, Kazakhstan, Uzbekistan are completely dependent on meltwater because it doesn't rain there. Those headwaters are actually in other countries. They're in Kyrgyzstan and so on, and
Yeah.
there's already water shortages there. So, I mean, if you put these various elements together of heat and lower crop yields and so on, I mean, we've seen climate lead to state failure.
Yeah,
I mean,
absolutely.
we've seen it in sub-Saharan Africa. We're seeing it. There's a big climate element in what's happening in Sudan.
Mm.
Um, the Syrian civil war was partly triggered by an epochal drought
Mm.
in eastern Syria that displaced more than 1 million people who went to the cities, and there'd been another million and a half people who'd fled from Iraq, and the cost of living, rent, food costs went up, and that led to basically it was the material basis for civil war. And as a consequence of that war, half the population of Syria was displaced. Half it internally, but half it externally into Turkey and Western Europe. And we can see that sort of forced climate
Oh
migration
yeah, absolutely.
issue.
Pakistan in 2022, almost 40% of the country was underwater and millions
Yeah.
of people got displaced. And it's horrifying. So um and you talked about a little bit in your paper that do we need to have high-end possibilities and not mid-range probabilities?
Yeah, yeah. Well, this is the thing. I mean, I mean, for example, Will Steffen and his authors on the hothouse Earth, when you could contribute this cascade of events, said, look, it could be between 2 and 3 degrees, maybe three, but then he said, and I quoted to you, it could be between 1.5 and 2.
Yeah.
If you're a risk manager, you're working for an insurance company, you say,
Yeah.
we really need to focus on the 1.5 to 2, not assume the best. And I mean, this is the problem that, I mean, for example, in the IPCC, they say we've got a carbon budget, which I don't think exists, with a 50% chance of not exceeding 2 degrees.
Mm.
And which is mad. And I talked to a great Australian scientist, Mike Raupak, who is no longer with us, and I said, if you've got a carbon budget with a 50% chance of keeping under 2 degrees, what's the chance it would actually get to 4 degrees? He said 10%. Because of the probability
Yeah.
distribution function, the uncertainty. And I mean, so people are going along to international COP conferences saying, yes, we've got
Yeah.
this carbon budget, and there's a 10% of getting to 4 degrees. And yes, I put my child on a swing with the 10% chance of them falling off and dying. No,
Yeah.
they wouldn't. So they have an immorality
Absolutely.
about policy making that they would never exercise in their personal lives.
So is there a way to artificially cool this planet? Is it a visible, like, is it a viable solution? And who's going to do? Is it like gonna be costly too much? Because like
Yeah.
maybe rich countries can afford it, but like the poor countries
Mm.
again will stay the same.
Well, interesting. A great climate science writer, Kim Stanley Robinson, who some people have read, wrote a book called Ministry for the Future, and
Hmm.
it's actually set in India. And it starts off, the opening chapters is this incredible heat wave, what you were talking about in India, and just people are on roofs and dying and so on. The Indian government just says, we've had enough, too many people have died. We're going to start to put some sulfates back in the atmosphere to cool it unilaterally, just because this is out of control. So it's not an unreasonable proposition. So I mean, obviously, there's three things we need to do. The first is to stop using fossil fuels. As I said, every new fossil fuel license is a death certificate for a few 100,000 or a few million people. It really is.
Yeah.
The second thing is we need to get CO2 out of the atmosphere. It's obviously too high. I mean, the CO2 in the atmosphere, as we just talked about, is the highest in 16 million years. So,
Yeah, but it's very tough. It's very difficult to do that.
well, you could say we're going to stop knocking down forests. We are
That's
actually going.
easy. That's easy.
We
Yeah.
can we're going to restore forest.
Yeah.
The second thing is there's a lot of emissions from degraded wetlands. Let's
Yeah.
restore the wetlands. If you actually went out and restored nature to the best of your ability, that would be a start. The
Mm.
second thing is we know in agriculture that sustainable agriculture, you can use practices which hold more water in the ground, which result in less CO2 being released. So I mean, over a period of time, there are things we can do. It's not quick, but
Yeah.
we can get CO2 down. And then obviously, even if we do that, we're still going to get to 2.5 degrees of warming, and that could be kaboom for civilization. So the proposition is there anything we can do in the short term to cool the system until we get these longer things to work? And
Yeah.
the answer, I mean, big picture is yes, because we can see what aerosols have done. I mean, in
Yeah.
burning fossil fuels, we put all these sulfates in the atmosphere, which have masked probably a degree of warming, and they make cleaner fossil shipping fuel policy, take the sulfates out, and warming boosts. So we know big scale. The same with volcanoes. Volcanoes put a lot of sulfates into the air, and they produce temporary cooling for a couple of years. That's well known. So, could we do this? Would it work? Yes.
Mm.
Would it have side impacts that might be good? Yes. And there's a lot of research and testing going on at the moment. And to me, the question is because I don't think there's any great options anymore. I
Mhm.
think there
They're running
are.
out of options.
We've got least worst options.
Mm.
We've got what's the least bad path we can go down, and if what's called solar radiation management, putting sulfates in the atmosphere, but there are other things, marine cloud brightening, pumping misty sea water into the air to produce more clouds because clouds will reduce the thing. I mean, I think we should really seriously look at those things because the other option at the moment is heading towards a social global collapse. I mean, yes, it will be uneven. I mean,
So
Pakistan and Bangladesh and Sudan will suffer more than
than other
parts
countries.
of
Yeah,
Northern Europe,
absolutely.
Australia will,
And
because
they are the least responsible for
of
climate change.
course, of
Um,
course, and that's the irony.
yeah, that's irony, true, because these people are enjoying the best lifestyle, and those people still
Hmm,
trying to achieve that lifestyle and already trying to, change
yeah.
that. So before we end the segment, I want you to ask one more question: is that what do we need to talk more, which we are not talking about, when it comes to climate change?
I was briefing an Australian politician last week,
Mhm.
and I said, you understand that the oil and gas industry intend to expand production to 2050. And this politician said, what's the evidence for that? And I thought, oh my God. And then I said, and you understand that the world is heading towards 3 degrees or more. And the politician said, what's the evidence for that?
Uh,
And then I thought, and it's true because I've done a lot of this. The elite don't want to get the problem. I mean, the discussion at COPs at IPC at COP conferences is delusional. I mean, net zero 2050, and it's rubbish. It's made up.
yeah.
Um, so I mean, I don't think you can solve. You can get to an answer unless you can articulate the problem, the question. And I'm not sure at an elite political level
Mm.
that people get the problem because the politicians in Canberra internationally, they go to conferences and people talk about keeping 1.55 alive and we will honor the Paris Agreement and, we've got net zero and we've got all these possibilities and they believe it because that's what they hear all the time. And they
That's
don't hear from people like you and I saying, "Hey, folks, the system's out of control, we're heading towards collapse." And they go, "Well,
true.
that's a bit, those crazies on the side." So I think there is a real cognitive disjunction between the reality and that's not the whole answer, but I think that's we have to start there. And I think we have to understand, as I said, that we have to make some difficult choices and try everything that might work because, we are way past bedtime now.
Yeah. So yeah, thank you so much, David. That was a great conversation. Even though we had some hiccups in the beginning, but I think it worked out well. Thank you so much for your time. I appreciate that.
My pleasure, Mohammed. Great to talk to
Yeah,
you.
thank you.